Hello Math 7 students, this is Unit 2 Lesson 6, Using Equations to Solve Problems. This is part 2 in our two-part video series covering this lesson. A quick review, we only made it through one little section yesterday because I really wanted to emphasize the importance of an equation. Once we write an equation, we can use that equation to answer any type of question. We had a situation where we had the number of tickets sold and the total dollar amount received from those tickets sold. We used it to write a question, and we used it to write an equation, and then we used that equation to figure out, no matter what number of tickets I'm selling, how much money that's going to be, and we can reverse it, how much money there is, reversing that equation, solving for t and dividing it in order to figure out the number of tickets that were sold. So when we write the equation first, we can use it to solve all sorts of problems. With that in mind, let's look at our next example. 6.3 Recycling. Aluminum cans can be recycled instead of being thrown in the garbage. The weight of 10 aluminum cans is 0.16 kilograms. And the aluminum in 10 cans that are recycled has a value of 14 cents. If you look ahead, we do see questions 3, 4, and 5, we're writing different equations. If you write those different equations first, I think that they will help you answer these two questions. We've also talked about in the past how there are two different equations for each proportion. So what am I asking for when I'm asking for these three different equations? I want you to pause the video, read through those equation questions, read through the situation again. Can I write three different equations? Pause the video now. As I wandered around the room checking student work, I realized that they might need a little bit of a reminder of a strategy that we used yesterday. So you'll remember yesterday when I was getting ready to write an equation and to start looking through the information in this problem, I set up a little table. I know there's not space to set up a big giant table, but when we can set up the table and start looking for that relationship between the two quantities, it's a lot easier to write those equations. So with that in mind, as I'm asking you to write an equation that represents the number of cans given their weight, we're looking for the cans and the weight. So I'd be setting up a little table with that information. It might look something like this. Cans and weight. There are 10 cans, and the weight of those 10 cans is 0.16 kilograms. So we're looking for a relationship here. And again, maybe I don't know how a 10 changes to a 0.16. And that's okay. We can find the unit rate. Change that 10 into a 1. Which means I will be changing the 0.16 in the same way. Dax, you said you found the unit rate? What is the unit rate here? 0.06, is that what you said? 0.16, yes. So there's our unit rate, and now we can ask those questions. How does the 1 change to a 0.016? You can also set this table up in the reverse order with weight and cans, where now the weight is in the right-hand column. The cans, I just said that backwards, the weight is in the left-hand column and the cans is in the right-hand column. Where now, what if I wanted to know 1 kilogram, how many cans is that going to be? I would still need to find the unit rate and then figure out the number of cans. Once I do that, it's again easy to ask that question, well, how does the 1 change into whatever is over here? So set up your little miniature tables. That will help you identify that relationship going forward. So pause the video until you've got those equations written, and we'll go over them together. Okay. We have now spent a few more minutes working through these. We're just going to go over this all together as a class, and online learners are going to make sure that they are getting the same answers that we came up with here in class. So, what is the unit rate for weight? How do I change that 0.16 into a 1? How do I change any number into a 1? Gabe? We divide it by itself. So even if it's a decimal, how can I change the 0.16 into a 1? We divide it by itself. So what should I be doing here? 10 divided by 0.16. Calculate that for me. What did you get? Everyone just quickly started typing it into their calculators because they didn't do that before, so they're quickly doing it now. Danielle? 62 and 5/10. That sounds about right to me. Is that what you guys got as well? All right, so now we've set up our two different tables, forwards and backwards, only it's not really backwards because I've reversed those tables, right? So it's kind of still forwards in both of them. And as I go forward in this table, I multiply by 0.16. And as I go forward here in this table, I'm going to be multiplying by 62.5. And so using the variables that it's given us, W for weight and C for cans, we can now turn this into an equation. If I have C, I'm going to multiply it by 0.16, and that will give me the total weight. But if I know the total weight, then I can multiply that by 62.5 to figure out the total number of cans. So again, we've got our two different equations. Which one is the one that they are asking us for? It says write an equation to represent the number of cans given their weight. Carter. That is actually incorrect because it says C given their weight. So that means they would tell us the weight. We would use that weight to figure out the number of cans that would be. So it's actually a little bit backwards from what we read. So it says given their weight. Given their weight is what is going to be here in this first column. And now, given that weight, let me choose a different color actually. Given their weight, we can always go forward and figure out what the number of cans is going to be associated with that. Is it bad if you wrote this equation? No. It's just the reverse, right? And yeah, honestly, it's just the reciprocal. We can't see it based on the numbers that we're using. We can't see that reciprocal relationship. But yes, based on our past work, we know that 0.16 and 62.5 are reciprocals. If I were to actually write those as fractions, they would be reciprocals. So it's okay if you wrote this equation. You would just have to do a little bit of work to actually answer that question. Okay, with that in mind, let's set up these next ones. It says write an equation to represent recycled value of R of cans. So now I'm still taking care of the cans, which is going to be variable C, only now I'm looking at the value, which they're going to call R. Eventually, I'm also going to want to flip that table because I want to be able to write two different equations so that I can know which equation is going to be the most helpful. We have R value and cans is C. Let's look at the original problem for that information to kind of get us set up. The cans, looks like that is 10 aluminum cans. And those same 10 cans, when they're recycled, will bring in 14 cents. That's the recycled value, or R. So that'll be 0.14. And we'll reverse it here in this table. Our first step, we're just really baby stepping this here. Our first step is going to be to find that unit rate. How does the 10 change to a 1? We divide it by 10. So for just one can, what is that recycled value? 0.014. And even though we're dealing with money, I don't want us to just stop at that nearest penny because that 0.4 of a penny is going to continue to add up. So I'm going to include that extra decimal here. And what about the unit rate for this table? That 0.14 is going to change to a 1 by dividing by 0.14. So the 10 divided by 0.14, you'll have to help me out on that one, the calculation, Seth. 428. We'll stop there after 3 decimals. Is that good? Did I get the decimals right? 71.428? Okay, and now again, finding that unit rate really helps us figure out, okay, what are we doing as we go forward? Here we're multiplying by 0.014, and here we're multiplying by 71.428. So again, we've got our two equations ready to go now. This equation says we're going to take C, We're going to multiply it by 0.014, and that's going to give me the recycled value. Here, we're going to take our recycled value, we're going to multiply it by 71.428, and that will tell me the number of cans that I recycled. Two equations. Which equation is the one that they're asking for? Write an equation to represent the value R of cans. So that means we know the number of cans. We're trying to figure out, when I know the number of cans, how much money am I going to get? And so it is actually C times the 0.014 is equal to R. How many of you guys figured out the right one there? Most of you. Okay. And let's finish up here, our final one. Write an equation to represent the recycled value R of W kilograms of aluminum. So we've got our value, R, and we've got our weight. Is that what the W is really standing for? Yeah, weight. W. Here in this table, I'm going to reverse those columns. Weight W and value R. I have to go back to the original problem. The value is 14 cents with a weight of 0.16 kilograms, because something that's worth noticing here is that we're doing 10 aluminum cans and 10 cans. So the cans are all staying the same there. So the weight of 10 cans is 0.16 kilograms, and the value of those same 10 cans is 14 cents. So the value is $0.14 or 14 cents, and the weight is 0.16. Going to reverse these over here, and we're going to find our unit rates for both of them. How does the 0.14 turn into a 1? By dividing by itself. So 0.16 divided by 0.14 is equal to, help me find the unit rate on that one if you haven't already. Thank you, Gabe. Quick hand. 1.143. And let's figure out the unit rate here. If I'm changing the weight into 1, so for just 1 kilogram, dividing by 0.16, 0.14 divided by 0.16. Thank you for those quick calculations, Seth. So 0.875? Great. And again, finding that unit rate is a great step, because do you know how a 0.14 changes to a 0.16? No, but do you know how a 1 changes to 1.143? Very easily. So when we take that baby step of finding the unit rate, it really helps us think through these problems. The 1 changes to 0.875 by multiplying by 0.875. So again, we know what we're doing. We're starting here with R, the value. We're taking that and multiplying it by 1.143, and that gives me the weight. So if I know how much money I made, I can figure out how many pounds or kilograms it weighed. Or if I know how much it weighs, then I can multiply it by 0.875 and figure out how much money I'm going to get, which is the equation that it was asking for. Represent the recycled value R of W kilograms of aluminum. Which is the equation? Raise your hand if you think it is this equation that it was asking for. Raise your hand if you think it is this equation that it was asking for. Yeah, you guys got it right. We're given the weight, or we know the weight, so we want to find the value of those aluminum cans. Now that we've gone through all that work of writing our 3 different equations, and honestly, we actually wrote 6 equations, didn't we? And that's what I really wanted you to recognize, is we talked about there being 2 equations per proportion. We actually have 3 different proportions here. We can make a relationship between the weight and the number of cans. They are proportionally related. The more cans you have, the more they're going to weigh, which means there's 2 equations for that. We also can write a relationship between how many cans we're going to recycle and the amount of money we're going to make. So again, you can see 2 relationships, 2 equations for that one single relationship. And we can also then write the relationship for the value of the cans, the money that we're going to get for recycling them, and the weight. So again, 2 equations for that 3rd relationship. Now we're ready to go back and actually answer these questions. what I want you to do, even though it says just answer the question, I want to identify which equation are you going to use. Which equation are you going to use for this first problem? It says if a family threw away 2.4 kilograms of aluminum in a month, how many cans did they throw away? Think about the question. We're looking at the weight and we're asking about how many cans. Which equation do you want to use? Even if you already answered this question, because I know some of you already did, answer the question I'm asking you. What equation do you want to use? Talk with your group members. What equation do you want to use? Okay. Let's come back. Let's decide. Let's start going with the ones that we obviously aren't going to use. Are we going to use the one that relates the weight and the value? No, because that's not what we're asking for. We're asking for the weight and the number of cans. So am I going to use the number of cans and the value? Again, that's not what we're asking for. It doesn't ask anything about the value, just about the cans and the weight. So it limits us to these two equations. Which equation do you want to use? Dex? Good. And why did you choose to use that one? Good. So if I use this one, the W times 62.5 is equal to the cans. So let's write that one down. W times 62.5 is equal to C, or the cans. We know what W is. It tells us right here in the problem, so we're just going to take that and substitute in that 2.4. And all I have to do then is multiply it by 62.5, and it will give me the number of cans. I'm curious, is there anybody who chose to use this equation? Can we use this equation? Yeah, we can. Let's watch and see how it's going to be done. Okay. What we know this time is 6 times the 0.16 is equal to W. What do I know? I still know the W. It's just that the W is at the end of the equation, and that's okay. We still just substituted it in, just like we did here. Here, once I do this calculation, C is already alone, so I know how many cans that's going to be. Here, C is not alone. And that's not a big deal, because we know how to get it alone. What is that step that I would need to take if I wanted to get C alone? Let's see, C is being multiplied by 0.16, so I would need to undo the multiplying by 0.16, and I would do that by dividing. Whatever I do to one side, we do it to the other side. And now C is alone, and C is going to be equal to 2.4 divided by 0.16. Are these two answers going to give us the same thing? Because here I have the 2.4 and I'm multiplying by 62.5. Here I have the 2.4 and I'm dividing by 0.16. So which one is right? Cassandra? Good catch. Going all the way back here to the beginning, I did make a mistake. 0.016. And yes, that will make a difference. Very good catch. This will take me a second to recover from that. But yes, let's make that correction so that we can actually do what I'm trying to do here. 0.016 is equal to W, so I would need to divide not by 0.16, but 0.016. And whatever I do to one side, I'm doing to the other side. So C is supposed to be equal to, this isn't W though. We changed that W to 2.4. Does everyone see? I'm just following through that mistake, fixing everything. So now it's 2.4 divided by 0.016. I hear those calculator buttons are going. 2.4 divided by 0.016. And what did you get, Seth? 150 even? Okay. And what about here? 2.4 times 62.5. What do you get? 150. So does it matter which equation we end up using? No, as long as we chose like the right category of equations, right? We're not going to be using weight and value when it's not asking for that information. As long as we're using the ones that relate weight and the number of cans, either equation you use is going to give you the correct answer. So how many cans? That would be 150 cans. Okay. Now, question 2, and this is where we're going to finish because I think it's summary page next. Yeah. What would be the recycled value of those same cans? Again, listen to the question I'm going to ask. Which equation is going to be the best one to use? What is the recycled value of those cans? Visit with your groups. Which equation do I want to use? Okay, come back to me. What are your thoughts? Thank you, Peyton. Good, we should use number 4 because it's not mentioning weight. We know cans and we're asking value. So the ones that relate the cans and the value are probably going to be the correct ones to choose. So let's go ahead and use that. C times 0.014 is equal to R. Or if I wanted to, I can see the reverse of that one. The R times 71.428 is equal to the number of cans. But I know the number of cans now, don't I? The number of cans is 150. So I can take the 150, multiply it by 0.014, and that will give me the recycled value. What did you get, Gabe? 2.1. And since we're dealing with dollars, 2.10 or $2.10, right? Okay, what if we did it this way? Is there a little bit more work involved? Sure. But is it okay? Can we still use that equation if that's the one we chose to use? Yeah. What's happening to R? We're multiplying. How do I undo multiplication? Division. There might be some rounding issues here because of where we rounded our numbers earlier. R is equal to, type this in, 150 divided by 71.428. 150 divided by 71.428. Seth, what did you get? 2.130,168,20. Hold on, you said 3 zeros? As in 2.1000? Okay. And again, since we're dealing with money, how many decimal places do we really need? Just the 2. So either way we did it, we got the same. We would need to say that the value is $2.10. Is there a lot of value in recycling cans? I mean, do you make a lot of money from it? No, but we don't do it for the money. We do it for the environment, right? 150 cans, $2.10. That's $2.10 that you didn't have before. Yep. Okay. Are you ready for more? I like this one, but again, it's not one that we can answer right now here in class. The EPA estimates that in 2013, the average amount of garbage produced in the United States was 4.4 pounds per person per day. 4.4 pounds of garbage that you produce each day. What do you think about that? At that rate, how long would it take your family, think about how many members are in your family, to produce a ton of garbage? A ton is 2,000 pounds. But we don't have time for that. Let's summarize. Remember that if there is a proportional relationship between two quantities, the relationship can be represented by the equation in the form y equals kx. Sometimes writing an equation is the easiest way to solve a problem. For example, we know that Denali, the highest mountain peak in North America, is 20,300 feet above sea level. How many miles is that? Well, there's 5,280 feet in 1 mile, and so we can write that relationship with this equation. F is equal to 5,280 m. F is feet, m is miles. So, if I want to know how many miles Denali is 20,310 feet above sea level. So what I've done is I've taken this F and I've substituted it in for 20,310. And now we have the equation 20,310 is equal to 5,280 times m. How do I solve this equation? We simply divide each side by 5,280. So m is equal to 20,310 divided by 5,280. Calculate that if you need to, or trust that this lesson has it correct, and it's approximately 3.85 miles. So here's my summary for this. We can write equations, and I want you to add this to that summary wherever you can squeeze it in. We can write equations there are two per proportion. We can use those equations to solve the problems. And I want you to remember, does it matter which equation I use? Does it matter if I use the forwards one or the backwards one? No. The result ends up being the same. So you don't need to take a whole bunch of time writing those two equations. Pick one, trust that it's going to work, and use it to solve the problem. Now it is time for our lesson cool down. Based on her recipe, Elena knows that 5 servings of granola have 1,750 calories. If she eats 2 servings of granola, how many calories does she eat? If she wants to eat 175 calories of granola, how many servings should she eat? Don't answer either of those questions until you have answered question 3, writing an equation. And for the sake of time, I would normally like for you guys to work on this on your own, but I want to finish while we still have class time. So we're going to skip to number 3, and I want us to get in the habit of writing our equations by setting up the little baby tables. So we want to know the number of calories and the number of servings. So this will be our servings, which maybe I'll use the letter S for servings. Make sure it looks like an S and not a 5. And this will be the calories. I'll probably use a C for calories. So I've got my little baby table set up, and I don't need to put a ton of information. We'll put the given information, like 5 servings is 1,750 calories. And then I really like finding that unit rate. How does a 5 change to a 1? You divide by 5. So 1,750 divided by 5. Thank you for those quick calculations, Gabe. 350. Again, how are we doing this? It's very simple. I'm just dividing by 5, and this would also need to be divided by 5. And now how does the 1 change to a 350? We multiply by 350. That's the reason why we find that unit rate, because it's so much easier to answer those questions. So if I know the number of servings, all I have to do is take the number of servings, multiply it by 350, and it is going to tell me the number of calories. We wrote an equation. Do we need to write the other equation? No. Even if the question said calories in terms of granola or whatever else, I don't really care. We wrote one and it's good enough. Let's use just that one equation to answer question 1 now. Servings times 350 is equal to C. But how many servings am I using? 2. So we're taking that S. We're substituting in the value of 2. 2 times 350 is equal to C, which is 700. So how many calories in 2 servings? 700 calories. Let's use the exact same equation here, because there's no reason to write a separate equation. We can use the same one. It doesn't give me a whole ton of space, so I'm going to use it over here. S times 350 is equal to C. What if she only wants to eat 175 calories? Well, this time I'm substituting in the C is 175. S times 350 equals 175. How do I get S alone? We divide by 350. That's how I undo the multiplication. Whatever I do to one side, we do it to the other side. And we get S is equal to, we'll wait till you guys get that typed into your calculators, 175 divided by 350, Dean? 1/2, exactly. So the number of servings is 1/2 of a serving. 1/2 a serving is 175 calories. That's why it's important that when we're choosing our variables, if it doesn't give them to us, choose your variables so that you remember which is which. S for servings, so that when it gives me the servings, I know I'm changing variable S. C for calories, so that when it gives me the calories, I know I'm changing variable C for calories. And then just solve your equations. That's it for today. Your homework is the lesson 6 practice problems. We'll see you next time.